So welcome to Lecture 20. This is NRGY 101. We're in week 10. And I want to spend the first little bit here. Oh, let me attach to the screen, guys. Sorry about that. I want to spend the first little bit here actually talking about the 2016 practicum. Tim Chester and I were just chatting there in my office, and one thing that he would like to we try to do different projects every year, so it gives us as instructors a broader skill set and exposure to different technologies. But what we're interested in building for the 2016 practicum is a rocket stove. And a lot of times these are, you can see there's a wide variety of them. A lot of times they're kind of homemade. There are a few commercial products out there, but the idea, rather than burning sort of warm and long, you burn hot and short, and so you get a lot of heat out of it, very little particulate, and nearly complete combustion. And what we'd really like to achieve with this is something we can actually monitor. So monitor the exhaust gases on it to see, how it compares to just like a fireplace, for example. Because as you probably know, you can't put a new fireplace in Missoula Valley. But if we come up with a stove that does not emit the particulates that people don't want to breathe, CO, carbon monoxide, SOx, NOx. There's also there's phosphorus in wood, stuff that you really don't want in your lungs. If we could come up with a standard for that, I think it'd be a great project. So start thinking about this a little bit. Another project that I want to build is this thing I'm just going to call Maxwells Demon. And more or less, I'm not going to get too deeply into it, but more or less what it is, it's a thought experiment for taking two bodies of gas, and you could imagine one body of gas just being, for example, the air inside this room. I just walked in, it's much warmer in the room than it is outside. Taking two bodies of gas that were initially the same temperature. So imagine, 9 o'clock in the morning, I had the windows opened up, and so whatever temperature it is outside, it's the same temperature inside. This Maxwell's Demon, it was a thought experiment by James Clerk Maxwell, and I think we did a little bit of Maxwell's equations when we were doing the electricity chapter. So the idea is that you've got some little entity or person looking at the individual molecules in the air. And anytime there's a hot molecule moving in the direction from A to B, he opens the door. And anytime there's a cold molecule moving from B to A, he opens the door. So the hot side gets hotter, the cold side gets colder. So in general, because in the air we're breathing, air that's moving around us, some of the particles are moving really fast. Some are just kind of sitting there. It's just, imagine a billiard ball table, right? And depending on exactly where each ball is, they're constantly exchanging energy with each other. So the idea is, let's just open this little door and let the hot go one way and the cold go the other way, and make an engine from that. Because like the other technologies we've been talking about so far, internal combustion, coal-fired power plants, they're all thermal technologies, and they rely on this thermal gradient. Hot over here, cold over there. And the demon part, or the paradox part, comes in. It's like, well, you can't really do this. It violates the second law of thermodynamics because it takes some energy to open that door. Like some energy has to go in, just like when we studied the Carnot efficiency. You're only going to get a certain amount of work out when you do a heat transfer. But what I would like to do with Maxwell's Demon would be, say, to have, again, two reservoirs, one that's hot, the other one that's cold, and you could imagine these being underground, for example, in insulated tanks. And at night, when the air temperature is cold outside, you're sort of pumping cold energy underground, if you will. Low temperature air. Maybe you've got a radiator with a fluid in there that can go sub-zero, so you could actually have a cold storage unit underground that was actually ice cold, just block of ice, just like a root cellar. So at night, the cold side gets colder, and in the day, the hot side gets hotter. So the demon, if you will, is just the heat exchanger above ground that's deciding when to send cold down on at night and when not to. Once you reach equilibrium, like if you're not going to make it colder, don't send anything down there. So, and I think the rocket stove is a good way to do that. If you got extra heat coming out of there, send that down to the hot reservoir. So, anyway, something to think about for next summer's practicums. We'd like to have people signing up for that. Well, start thinking about it now, and then we'd like by April or May to have the teams actually established, buying the parts, getting the drawings going, and so we can really hit the ground running for that 2016 practicum. Should be a good one. Okay. That's all I want to talk about on that. Now that Tynan's left the room, we can look at summer 3. All right, so Tynan has been gracious enough to allow us to dissect his summary 3. Upload for grading. Okay, so there's 16 people in Energy Y 101. I think Tim started doing some grading, but decided he would just leave that to me. There's a few little subtleties in here that are a little tricky, but doable. Okay, so here's Tynan's. I'm just going to grab that, open that with Word. It sounded like Tynan was having some trouble with the exponential function in Excel, so I'll first go through the summary, see what's good, see what's bad, and then dig into the Excel. Okay, so File, Save As, Documents, Courses, Spring, oops, Fall, yeah, make this a little bit bigger. Always a good idea to put a date on here. And I'm going to put that in green. So green meaning add. Population boom. Not that big a deal, but this should be caps. So that's going to be red. That's going to be green. Population of the world is growing faster than can be imagined. Well, it might be true. I mean, it is kind of hard to imagine.
Well, if you go to that site, it's just
faster than your eyeballs can roll back in your head. In one day, the population grew. And now I'm going to be a little bit overly picky here. And in one day, the population grew by approximately 250,000. This growth is also leading to the usage of carbon-based fuels. Here's what little trick I learned along the way. So carbon-based is a compound adjective, and I'm going to remove the space, and I'm actually going to put in Control-Shift-hyphen. Doing Control-Shift-hyphen turns that into a non-breaking hyphen. So if I just put a hyphen in, you might think that carbon-based is all one word, but it's not. So for completeness, I'm going to put put in that non-breaking hyphen because carbon-based is an adjective that modifies the word fuels. Okay, using more carbon-based fuels is causing an increase of carbon monoxide emissions into the atmosphere. Did you mean monoxide or dioxide? Or?
Dioxide.
Yeah, well...
I said it more than once in here.
Yeah. So,
CO2, not just CO2.
and both are true, and both have their issues. I mean, carbon monoxide, I don't think lives quite as long. I think it's not as stable as CO2, and eventually sort of becomes CO2. Obviously, one really bad thing about carbon monoxide is it can kill you if you breathe too much of it. Okay, in one day. So, sorry, did you mean to say dioxide here?
When I wrote it, I was thinking mono was two, not.
Oh, right. Okay. All right.
I don't know why.
That's fine. All right. I'll just change it. I'll just dioxide. There we go. One day carbon dioxide emission raised. I would say here you say equaled. Right? If I can spell equal. Approximately 115 million tons. Another thing too, this is just for legibility. I'm going to hit a backspace, and if I do a control-shift space, that'll be a non-breaking space as well. Sometimes it's just easier to read if the number and the units are right there on the same line. Okay. The growth rate and carbon emission rate continue on ahead to the conclusion. There needs to be a change in the way and amount we use our carbon-based fuels and how the human race procreates. There we go. Okay. Another data point that was viewed. I heard China's going to lift its one-child policy. You guys heard that? Yeah. And you might say, "Oh, is that good? Is it bad?" And they have. I mean, they've got an issue where the demographics. They don't have enough young people in the workforce to provide the Social Security for the old people that aren't working. I guess a little low on that.
They only were allowed to have one. They made it so they had one male.
Yeah, and I don't.
To continue the family legacy.
I know, that seems kind of strange that the male-female thing happens the way it does. Well, I've not visited China, and I don't know that much about the culture, but that is a little curious to me as well. Another data point that was viewed was the relation, ratio?
Yes.
Ratio between the overweight people in the world compared to the world population. Currently, there are approximately 1.6 overweight people. That's overweight. Similar day. Something has changed. Good. And that's the way you've written this is perfect. So you sort of say, what you're measuring. You give some numbers. That's critical in this type of assignment. You actually put some numbers out there, and then what do we need to do about it? It's a problem. You identify what do we do about it? Change that to dioxide. 60 million. 6 billion tons. So again, I'm going to go to the end there. Control shift space. This number is yeah. You know what? And on the very short time period we're considering, a linear model is appropriate. And I use this analogy a bunch. So, back in the day, there was the whole flat Earth theory. The Earth was a pancake instead of a ball. And in some sense, it's true. A big enough ball, if you get close enough to it, starts to look pretty flat. So anything, well, I guess until you get close enough. I mean, my hand looks pretty flat. If you were a little tiny ant, you'd be crawling over wrinkles and hairs, all that. It gets crooked again, but at some scale, large curved things are in fact flat, so the linear model is, as you say here, appropriate. So good job getting the mathematical model into your narrative. Perfect, yeah. 60 days, and then we're overweight people, about 3 million. Yeah, okay, good. And you put it in perspective. Perfect, perfect. Okay, now, so your figures are not in here. I would like them to be in here, and I'll show you how to put them in here.
Okay, I just uploaded the Excel.
I saw that, but, another part of this 101 exercise is to get you comfortable manipulating these documents. So this is a perfect opportunity for me to go over how to do that. So I'll open it, enable it, file, save.
Well, one thing that I might have messed up on my exponential is the video you posted over the weekend.
Yeah.
After we emailed.
Yeah.
I thought you had said divide.
I think I said divide, but I also tried to correct myself and see, it's gonna be one or the other. One's gonna be incredibly wrong and the other one's gonna seem about right. So, in fact, we're gonna do a little bit of that time constant stuff here with chapter 10 and nuclear fuel, because there's exponential decay. And, I mean, I guess the answer there is, multiplying by 10 is the same as dividing by 0.1. So fundamentally, division and multiplication are the same operation, and you only have two choices, and it should be obvious which one's wrong in terms of how Excel spits back the data.
Then on your summary video on Tuesday that you you put in multiplication.
I did. That's right. Yeah, I did. That's exactly right.
I don't have much experience with this.
That's all right. No, and a lot of times people come and say, "Well, I don't understand Microsoft Excel," and I'm like, "It's okay. That's what school's for. You're in the right place, because that's what we're trying to achieve here." I mean, we're not trying to make you a Microsoft Excel expert by any means. This is just one relatively modest introductory exercise for using a very common software package that, well, the majority of people working in technical fields do know how to use. Okay, so here are your, I got two sheets. Okay, this is nicely organized, by the way. Thanks for doing that. Okay, so I assume here, tying in, okay, perfect. So you've got your linear up top, and you've got your linear 60-day with the extrapolation on the bottom. Nice, okay. Here's what I'm going to do to this sheet, this chart. I'm going to see if I can't add axis titles. There we go. So put that on there. What's this? This must be population over here, right? Good. So population, P-O-P-U-L-A-T-I-O-N, and it's conventional to put the name of the variable and then the symbol of the variable. It's even more conventional to put in the name, the symbol, and the units. In the case of people, there's no units. It's obvious that it's just an integer, so we can just keep it with that. This is, so to be complete, we would say time, which the symbol of which is T, and it's measured in days. So that's kind of reduces the ambiguity. And on this side, this is going to be CO2 emissions. And I don't think we really have a unit for it. It's okay, but it's measured in tons, I believe, right? All right, so we got that. And what I should have done is done it on the bottom chart because that's the one you want to put in the figure. But I'll do it again really quickly. So this axis titles, put those on. This is population N, no return. This is time T in days. Then over here, this is CO2. Okay, now which line is which? The orange one is population, the blue one's CO2, right?
No, the blue one's population, the orange one's CO2.
The blue one's population, okay. So let's do a little bit of that because it's not immediately clear. So I'm just going to take this guy and so this graph is obviously CO2. The right side are in tons, yeah. So I'm going to put that, I'm sorry, tell me one more time, is it orange or blue?
Orange.
Orange, okay. So I'll just make that match that color. And I'll make this match the blue color. See what I just did there? Now you can just look right at it. And I'll show you another trick on that too in a second. Okay, now you say you're pretty comfortable with the linear? I think I went over that pretty extensively in class. Looks like you came up here, you said y equals mx plus b. Here is m, so you just copy that in there, and I'll turn that into a number so I can make sure the comma's in the right place. It's a pretty common error to just not get the right number of digits. And then control 1, number, dink, dink, comma, okay, all right. So it looks like you put that in there, and then this line, so we're looking at population, this line is here, and I can see that in this cell, you just y equals mx plus b, perfect, no problem. Quadratic, scroll over a little bit.
There are negatives, but if I put in the negative, it reduced it by a couple billion people.
Oh, really? Okay, that's a good one. Let's look and see what those coefficients are.
I use positives.
Oh, okay.
I didn't imagine that the population would decrease by so many people.
Oh, I see. Okay. Now that is an excellent question. So what I'm seeing, and hopefully you can see this. Let me make it a little bit bigger. So with your linear model, you're going to have two coefficients. You're going to have the slope, and you're going to have the y-intercept. With your quadratic equation, you're going to have three coefficients. We'll just call this one A, we'll call this one B, I'll call this one C. A is the coefficient on the squared term, B is the coefficient on the linear term, and C is, in fact, the y-intercept. So, what does a negative value for A mean? And if you if you haven't gotten to this in algebra or been in like a pre-calculus class, you would not know the answer. But let me, I'll tell you what negative A means. So it's a parabola that we're plotting, obviously, and there's really only two directions the parabola can face. It can either face up or it can face down. So if we were just to plot y equals x squared, it would be facing up like this. It would have a minimum right at 0, come down, slosh back up. That's y equals x squared. In the case of y equals x squared, A just equals 1, and it's positive. If we plotted y equals negative x squared, it's just the same, it's just the mirror image of that. So all this means, all this negative thing means, is that if we kept tracing this parabola, eventually it's going to go down. And in some sense, if you sort of look at the trajectory of most things in nature, they don't last forever. I mean, there's no more dinosaurs around. There's no more, I don't know, a lot of species have gone extinct. And a lot of people argued that our own species is sort of reaching an apex. You know, who knows if humans will make it or not, you know. So there have been, I think something like, this is also kind of weird to think about, but since we had a common ancestor 70,000, 200,000 years ago, there have only been about 80 billion humans ever on the planet. And the weird thing to think about is almost 10% of all humans that ever lived are on the planet right now. So the time will tell what ends up happening to our species, but it's not unreasonable to assume that we are sort of peaking and that eventually we'll head down. So the negative is not incorrect in that sense. Whether or not it's correct at this little tiny 2-day scale that we can predict the whole trajectory of human civilization is a little unrealistic, but that's what the negative there means. So let's just see how you handled that. All right, so you got your coefficients, and so
I chose positive when I did it, not negative.
Yeah. Okay. So I'm just gonna go ahead and just double check these numbers. Ding ding. Okay. And then I'm going to go ahead and just put the negative there because that's what I'm reading on the screen.
I went back and forth with it.
Oh, I see. Yeah. Okay. Yeah. Oh, and then you're like, gosh, that looks pretty unlikely. Yeah. And I could see why you would make that conclusion. So, and again, the numbers themselves are not wrong. What might be wrong, and this is another part of the exercise, is to say probably the model's not right. It's probably not that wise to choose a quadratic function to model things of this nature, and I would agree with you for this very reason. And then it was the same thing on the CO2, right?
Correct.
Yeah. Okay. Well, and really what this means, if we zoom, we don't have to zoom in. The 6 little points right here in this figure are the same as these 6 points. This just means that the system is decelerating. It just means that the rate at which the population is growing is going down, and that's. Let me pull up another paper that was recently published that will corroborate that. While we have the chance. And you guys will see this paper 102 next semester. It's written by Shramsky. Yeah, these guys at the University of Georgia, in fact, just last night I was over at the Honors College, and our new dean of the Honors College comes from University of Georgia. So, small world. But the figure I was referring to is this one. So here's the human population, and if you look closely, this curve is bending down a little bit. It is decelerating. The rate at which humans are, even though it's still pretty alarmingly high, it is decelerating. Total energy consumption is also decelerating, and the question now is this because there's more poverty or more efficiency? Because in general, if you can use more energy, you're sort of healthier, wealthier, et cetera. And so this can either be looked at as a cause for concern if people are not getting access to the energy services they require, or it could be a cause for elation in that, hey, we've got better insulation, our cars are more fuel efficient, et cetera, et cetera. Okay. So hopefully that explains the whole curvature and the negativity there. All right. So you said there's an issue you're having with the exponential then?
Predicting my 60-day.
Okay. But you got a number, I see.
0.
Let me zoom in a little bit. I'm just saying that the model spits something back at you. So we're looking at y equals 7.3, et cetera, et cetera. That number is not that easy to see, but it's 4 zeros followed by 3, 4, 4, 6, 5, right? All right, so let's see what we can do over here.
I took that one pretty far out.
Let's see that. Okay, so you pulled the numbers. That looks good. I'm going to assume that's correct as well. When you get down here, you got B18, yeah, times EXP. Yeah, so just multiplication, yeah. And I apologize for being ambiguous on that. There is no division sign here, but if I took the reciprocal of that number, then I would obviously divide it instead of multiply it. So sorry to be unclear on that. Okay, so that looks pretty good. I think we do the same thing here. Fixed. All right. Now, the only thing left to do, and this is a really good job. Thanks for putting the effort in on this one. The only thing left to do, I'm going to take this plot, and I'm going to format the area, and on the border, I'm just going to say no line. It's just a little cleaner looking. And I'm going to take it. I'm just going to click. I just left-clicked in the box. I'm going to do Control-C for copy. Now I'm going to do Alt-Tab, and I'm going to keep hitting Tab until I get back to my document. And I'm going to come up here. Okay, so you've actually talked a little bit about this figure in the first paragraph, so I'm going to put in an enter. I'm going to get this on its own paragraph line. So I did Control-Shift-8 to turn the meta characters on. The meta characters are the spaces, the tabs, the paragraph returns. So now I can see those paragraph returns. I've already done my Control-C, and now up under Paste, which would be Control-V, I'm not going to do a Control-V because it's going to stick a Microsoft Excel document right in my Word document where I don't want it. But I've got my Microsoft Excel plot looking really good, so I'm just going to paste it like this. Boom, paste it right in as a picture. So again, paste, and then there's the little icon saying paste it as a picture, not as a active, okay. And now, I'll put my cursor right after that P, I'll do another return, and I'm going to insert, nope, I'm going to reference, I'm going to insert a caption, so and the caption is automatically calling itself figure 1, linear prediction of population and carbon dioxide emissions. Okay, and I'm going to do a Control-E, which puts that in the center. I'm going to highlight the whole thing. I am going to go here. I'm going to click on that, make it black. I'm going to make the font match the rest of, well, I'll at least make the font a little bit bigger. Make sure emissions is spelled correctly. I'll put a period there. And so now I've got something that's looking a little more like a paper. And the resolution isn't really sufficient here to see it, but I can come up here and go insert cross-reference, and I want to cross-reference a figure, so I'll select that. I don't want the entire caption in there, I only want the label and number. Now I'll insert it, and I'll close it. Okay, so that might have seemed like a lot of work. I don't know, maybe it took me 5 minutes to do it, but I do this for a living, so okay. But now what you have, you've got a nice little template, and so I can take this whole thing right here, copy it. I don't know where you want to put it in your paper, but I can paste it. So I just those two lines, the figure and the figure caption, I just copied and pasted it. If I come down here, update the field, it just turned into a 2 magically, automatically. And this is going to be quadratic. Again, I'll just take the whole thing, copy it, come right down here, paste it. Saving some work here. Exponential. Let this figure update. Update field. So I've got 3 out of my 6 figures knocked out already. You've already done a really nice job back in Microsoft Excel. I don't have my get rid of the border, put the labels on, Control C, Alt Tab, page up, delete, home, paste special figure. Boom. Just knock it out. So, so once you've got it looking good in Excel, it's just copy paste right in the document. And you saw, and you're also going to want to reference all the figures. So wherever you talk about the quadratic, figure 2. Wherever you talk about the exponential, figure 3. And it looks like you got plenty of words here, so don't kill yourself adding too many more. But hopefully that shows everyone, really start to finish how to do the summary 3. We collected the data, we plotted it, we formatted it, we wrote about it, and put the document together. So I'm feeling better. Okay, so let's take a break, and then we'll get back into chapter 10.